Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I want to give you a code review on a Kaggle community competition. The data set that we're using is the ARIMA models in Minitab and or Python. And basically what it was for these people who are students in this technology college. And if you were a student in the technology college, you had to use a ARIMA in Minitab and or Python. But if you're not a student in the technology college, they said that you can use whatever method you wanted. And so basically I tried to run this problem up in Ceramax, but it didn't work out very well at all. And so as a result of that, I just decided to stick with ARIMA. The only difference between Ceramax and ARIMA is Ceramax has a seasonal component, whereas ARIMA doesn't have a seasonal component. But other than that, the two models are the same. And so basically this is the second time I'm running this up because the first time I accidentally went out of it. So we're going to be talking a little bit more quickly since it's the second time I've had to do this. So I ran the program up on Kaggle's Jupyter notebook, and it is stored in my account for Kaggle. But what I will do is I will leave you a link to the Jupyter notebook in the description box down below if you want to study the code. So the first thing we're going to do is we're going to look at the problem statement. Problem statement is the purpose is to forecast 6 time series, no particular topic, using Minitab and Python. Minitab is a powerful tool to monitor and optimize. Well, I didn't use Minitab because I've never heard of Minitab. I don't even know if you can use Minitab in a Jupyter notebook. That's something that I will need to research, because if you're able to use Minitab in a Jupyter notebook, then maybe I should learn how to use Minitab as well. And then after we have read our problem statement, what we want to do is we want to import the libraries that we're going to use to run the program, which is NumPy as NP to create NumPy arrays and perform numerical computations, to import pandas as PD to create data frames and series and process data, to import OS to go into the operating system, to import random to create random numbers, from sklearn, pre-processing, import min-max scaler. So that would be used if we were going to scale the data. I scaled the data in another program, and whenever I scaled the data, the error was greater. So I decided not to scale the data in this particular program, but you can scale it if you want to. You are supposed to scale time series data, but since the time series predictions worked out better without scaling, I didn't scale them. Import statsmodels.api as SM, so that is the statsmodels library, and this is the first time I've used a statsmodels library to solve the Kaggle competition problem. So that's good. That's good that we're actually using statsmodels. Import Seaborn as SNS. What that does is that statistically visualizes the data. We're going to import matplotlib.pyplot as PLT, and that visualizes your data as well. We're going to import warnings, and we're going to ignore the warnings because I got lots of warnings and I didn't want to see them. So then we're going to set the seed. So random.seed is 42. So what that does is that is supposed to make sure that every time you run the program, it'll come out the same. So I set the random.seed 42. Now we're going to use the OS library to go into the operating system and retrieve the files that we're going to use in the program. We had 3 CSV files, being train, test, and submission. We're going to use pandas to read the CSV files and convert them to data frames. So we converted these 3 files to train, test, and submission. So this is your train file. You see that in your train file, you've got 6 series. So you've got really six data sets within one data frame. And you've got your indices and you've got your Y variable. So your Y is your label or your target. We check for null values. We don't have any null values, which is good, so we don't have anything to impute. Now we check the test file. The test file has ID, series, indices, but it does not have a Y column because that's what we're going to have to be predicting on. So we check for any null values. We don't have any null values, so that's good. We don't have anything to impute. Then we check our submission. This is what Kaggle wants to see when we submit our data. So submission ID equals submission ID. And so we're going to be using the submission ID. We've created a variable called submission ID. Going to be using that at the end of the program. And then so we're going to create a for loop to break the one data frame down into 6 different data frames. So num_unique equals train series.unique. For I in train series.unique, we're going to create a data frame for each different series of 1 to 6. And you can see here that that's what we've done. We've done it on both the train and the test set. So now what we're going to do is we're going to drop the ID, the series, and the indices on both the train and the test set. And the reason why is you don't need it, and the reason for that is because in pandas, each row of data is indexed already. So you don't need the ID, you don't need the series, and you don't need the indices. So you can see that now what we have in our 6 or 12 data frames really, on the train data frames you have only 1 column, and on the test data frames you have 0 columns. So now we're going to plot our 6 time series so you can see them. So this is 1, 2, 3, 4, 5, 6. So that's your 6 time series. And you can tell the difference that so number 1 has a trend, but it doesn't have a series. So I'm not really sure exactly how they thought you're going to use Saramax on a time series that doesn't have a season, because that's what Saramax is. Saramax has a seasonal element to it. So you've got seasonal data here. You've got a trend here. You've got seasonal data here, seasonal data here, seasonal data here, seasonal data here, seasonal data, and a bit of a trend here. So now what we're going to do is we're going to create a histogram of the 6 time series so you can see that. So that's 1, 2, 3, 4, 5, 6. And now what we're going to do is we're going to use a rolling windows technique. So we're going to roll it by 12. And this is what we got when we roll it by 12. So you can see number 1, it's much smoother. Number 2, you can see it looks different. Number 3, it looks different. Number 4, it looks different. And number 5, it looks different. And number 6, it looks different. So that's when you roll it by 12. So you could have rolled it, if you wanted to roll it by 12, the assumption is that each point is a month, and then 12 months will be a year. But if you wanted to roll it by 30, the assumption would be that each point was a day, and then you would have it monthly. But in this particular one, we just rolled it by 12 just so you can see what it looks like if it's rolled. So that's all we did, was we just plotted it. So now what we're going to do is we're going to check for stationarity, and all six are all six, the p-value is greater than 0.05, so all six have stationarity. So now what we're going to do, we're going to split the data frames up into testing and validation sets. And so we're going to do that by the train length is going to be 90% of the length of the train data sets. And then copy train, we're going to make a copy of the train data set. And then so the train length goes from the train data sets go from 0 to train length, and the validation data sets go from train length to the end. But you have to use copy train. If you don't use copy train, then it won't work right. And so now what we do is we check the shapes of the train validation and test, so you can see that. And I'm going to do something else here. Because this was splitting the data set. So we're going to do something else here. We have to set up the Y. We're going to set up our Y train and our Y val. So the Y train is your Y variable on the train set, and the Y val is the Y variable on the Y set. And so you can see here, we've got it all set up to where your Y train, your Y vals. So you can see the length of the Y train and the Y vals. It says we're going to check for null values. We don't have any null values, but because I was having some problems when I made it, I checked for null values, but we didn't have any null values. So I deleted that line of code. Now what we're going to do is we're going to create an ARIMA model. And what I did was I created a function. And so this function is a function of the ARIMA model. So you can see that this is the model right here where it uses PDQ. And it gets the best value. It gives you the best score. And then so the name of the function is getBestARIMA, but it takes a long time to do it, and so that's why I commented it out when I didn't need to do it anymore, because I had to do it for 6 data frames. And so when you get your best ARIMA, you put in the values into the model, which I did. And so I had an AIC of 700. And your AIC is a goodness of fit measurement. So number 2, you had to put in the order for number 2, and I had a 673 AIC. And then you want your AIC to be as low as possible, just like you want your RMSE to be as low as possible. So we're going to check number 3. We had an AIC of 280. Number 4, we had an AIC of 267. Number 5, we had an AIC of 1091. That was a hard one, and that was the one that didn't work on Serifmex. So I'm not sure exactly why they wanted to use Ceramax on this because it didn't work with Ceramax, and number 5 was the one that it didn't work on. And number 6, we had a 3230 AIC model. So those are your AIC models. AIC is a goodness of fit. Now we make predictions and plot. So we're going to have a def get y hat. And so you're going to make predictions on that. And then we're going to plot it. And we're going to return y hat. And then after that, we make another function called def evaluate predictions. So you've got your evaluation of your predictions function. So now what we're going to do is we're going to put in the first function, y hat 1 equals get y hat. And you can see this is y hat 1, and you can see green as your ARIMA forecast, and you can see what it looks like. And then number 2, and you can see the RMSE for this model is 45. RMSE is your root mean squared error. And now we check number 2, and you can see your prediction for number 2. Your RMSE is 16, so that's pretty good. We check number 3. This is your plot for number 3. Your RMSE is 1.5, so that's pretty good. Number 4, this is your prediction for number 4. Your RMSE is 0.59, so that's pretty good. This is number 5. This is the one that didn't work with Ceramax, or obviously I don't know how to use Ceramax that well, but I couldn't get it to work with Ceramax. And your RMSE is 12. This is number 6. This is what number 6 looks like. And your RMSE is 81. And now what we're going to do is we're going to predict on the test set. So I made another function and called it getPred. And so we check pred 1. These are your predictions for pred 1. Got your predictions for pred 2. You've got your predictions for pred 3, pred 4, pred 5, and pred 6. And now what we're going to do is we're going to concatenate the 6 predictions into one series. So predictions equals pd.concat pred 1, 2, 3, 4, 5, 6. So you can see you've got all of your predictions in one data frame now. And now we're going to prepare the submission. So my submission equals pd.dataframe. ID is submission ID. Y is prediction.values. My submission to CSV is my submission.csv. Index equals false. My submission equals pd.readCSV. My submission.csv. And here's my submission. And so this was my submission on the ARIMA. So those are all of your values. And whenever I submitted it to Kaggle, I got a best score of 321. And so that's the best one that I was able to get. Basically, I could try some more. I tried to do it on Ceramax, but obviously Ceramax is a more difficult model to use than ARIMA. And my error was too high with Ceramax, and it didn't work. It didn't work on number 5. So number 5, I had to set seasonality to false, whereas all the others were set seasonality to true. And so it didn't work on number 5 at all. So I'm not sure exactly why the people who created the competition said to use Ceramax or ARIMA. I did much better. I got a much better score with ARIMA. I guess I'll just have to do some more studying on Ceramax and see if I can become an expert on Ceramax. So that's it for this code review. This is what I submitted to Kaggle. I will leave the link to the Jupyter notebook in the description box down below if you want to look at the code. So thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you for watching my code review. I look forward to making more code reviews for you in the future.